So, how does it works? Okay, if we want to know how does it works, first of all, we need to know how a generator works. Okay, so let's imagine we have here a circuit in which this is the source. Okay, let's imagine this is positive and negative, and this is a wire. Okay, this is a wire, and this is an inductor, a shock, a coil, as you want to call it. Okay, whatever you want to call it. So if here a current is flowing through the wire, okay, a magnetic field will appear here, okay, and let's imagine this is the current flowing through the wire, okay, so the magnetic field will be this, okay, so here we have a magnetic field around the wire because a current is flowing through it, okay. So if we have, for example, many wires like here, all the magnetic field of each one will be added to a bigger magnetic field around this inductor or coil or what you want to call it. Okay, so this is a magnet. Okay, this is the north pole and the south pole. Okay, and for example, if we have here a paper clip or I don't know, a lace, it will be attracted by the magnet, okay? So it has magnetic domain lined up in the same direction in the same direction. So what does it mean? That here in the magnet we will have this magnetic domain. So it means that that a magnet is not a unique it is not a unique material in which if we cut it, for example here, if I have I don't know anything and I just cut it through here, I won't have here a south pole and here the north pole. No, not at all. If I cut here, we will have two magnets. Okay. So here we will have a magnet with south and north pole, and here we have another magnet with also a north and a south pole. Okay, because the magnet is the magnet just have magnetic domain lined up in the same direction. So okay, let's imagine that here we have two magnets. Okay, and each one has a north pole and a south pole. Same here. And let's imagine that I can spin it. Okay, so if I if if the same poles will be together, okay, it will repel the same pole. But if the opposite pole is here, it will attract the same it will attract the opposite pole. Okay, because they will try to line up both magnetic domains. Okay, so let's imagine this is this one, which I can spin. All the magnetic domains will try to be lined up. Okay, so but why did I say that if we have a current flowing through a wire, we can have a magnetic field? Because sometimes some ferrous material don't have the magnetic domain lined up. Let's imagine that this is, oh my god. Let's imagine that this is a lace. So if we have here a magnetic, if we have here we don't have here a magnetic domain lined up. It means that we have here many directions, okay, of the magnetic domain. So when we have a wire around this magnetic field, a wire around this ferrous material, okay, and a current flow flowing through this wire, here all the magnetic domains will line up when the current will flow through this lace, okay? All the magnetic domains will line up. It means that here we have the same magnetic, the same magnet, but the difference is that we cannot turn it off, but we can turn it on and turn it off when we want. We just need to turn it off, turn the source off, or turn it on, and the magnet will appear. The magnetic domain will be lined up when the current will flowing through this wire, okay? Okay, no more. And now, okay. So, this is the example, okay? Here we have first material, in this case a lace. So if I have here a current flowing through this wire, okay, all the magnetic domains in the lace will line up, okay, and it will be a magnet when I turn the source on, okay.